So I provided us with an ordered pair, and we're going to take this given point, and first we are going to graph it. So the given point is on a terminal side of an angle in standard position. Let's go ahead and let's do that. So we're going to go to a right, a distance of 5 square roots of 3, and then we're going to drop down -4. Now, a lot of you get caught up on like, well, how far do I go to the right? We're going to use this just to determine which quadrant does this point land in. So I'm going to go to the right because the first value is positive, and then I'm going to drop down. So I'm literally going to go to the right and drop down and make a point. This is 5 square roots of 3 and -4. I'm going to go straight back to the origin. And now the key, as we learned, is we're always going to go back up to the x-axis, making that 90 degrees. The angle closest to the origin will be the angle that I'm going to evaluate for the 6 trig functions. So in order to evaluate 6 trig functions, we need to know 3 sides of a triangle. And we know 2 of the 3 right now. This is a length of 5 square roots of 3. Remember, lengths are distances which are always positive. This is a length of 4. And a lot of students ask, well, why is it not -4? The negative sign told me to drop down, but the distance I go down is only 4. So how do I figure out this third side that's missing? Well, I'm going to use the Pythagorean theorem. So up top, remember, Pythagorean theorem is a squared plus b squared equals c squared. And most of us are like, well, that's pretty easy, Miss Bradley. And it's not that difficult, but it's easy for students to make mistakes. So I'm going to start with this first leg. And instead of writing a square, I'm going to write it twice because I know a squared means a times a. So 5 times the square root of 3, I'm going to write it twice. And a little bit different for 4. I could write 4 times 4, or I could just write 4 squared. Now the reason for the first leg why I wrote it out twice is because I see students make a very common error when they don't do this. So how do I go ahead and simplify this? I'm looking at the right like terms. So 5 times 5 is 25. And now the square root of 3 times the square root of 3 is the square root of 9. So I've multiplied these two quantities. Hey, I know the square root of 9 is simply 3. 25 times 3 is 75. So this portion, when I take the quantity 5 square roots of 3 and I square it, I end up with 75. And now I have 75 plus 16. Well, what is 75 plus 16? I know 75 plus 20 is 95. Take away 4 is 91. 75 plus 16 is 91. And normally we'd say plus or minus, but again, we're talking about a distance which is only positive. Now, as we spoke about in class last time, it's important for us always to reduce this. And so we are going to start, and you feel free to use your calculator here as a tool to do this. And I'm going to start with 91. Now, I know the first perfect square that's less than 91 is 81. And I know 81 is 9 times 9. So I'm going to go divided by 9 squared. Now, if I end up with a whole number, I'm like, yes, that means I can simplify this expression. Oh, I can't do that. I'm going to put this where you guys can see that better. Let's try this again. 91 divided by 8 squared, which would be 64. That doesn't work. 91 divided by 7 squared. And I'm going to go all the way. Oops, didn't mean to do that. 7 squared. Let's try this again. 91 divided by 7 squared. And I'm just going to keep going all the way down. And you're welcome just to watch here. And what I'm looking for, is there any value here? I'm trying to break this apart using these perfect squares. And we can see that none of these are able to break it down. Okay, we don't try 1. All right, so this is the square root of 91. Can I have, whether you were present or absent on the last school day, can I have a thumbs up or thumbs down if you're understanding right now? Thumbs up, thumbs down. Okay, next. Now, you have to remember what are the directions in order to evaluate the sine of this angle. So a lot of students forget, you've had the long weekend, and we're going to go with this acronym here. It's Oscar had a heap of apples. This is going to remind me for sine, for cosine, and for tangent, the 3 primary trig functions. It's going to allow me to create that ratio. Because remember, this is just a ratio of 2 of the 3 sides of a right triangle. Okay, here we go. We're going to get started. Ready? So I'm going to start here, and I will simplify them and put them into proper form eventually. Sine is opposite over hypotenuse. Okay, opposite is 4. Hypotenuse is the square root of 9. Now, I know the relationship between sine and cosecant. They're reciprocals, the square root of 91 over 4. Cosine is going to be the adjacent over the hypotenuse. So 5 square root of 3 over the square root of 91, and then I'm going to flip it. Tangent is going to be opposite over adjacent. Opposite over adjacent, and then I flip it. Mathematically, all of that is great, but at this level in math, we need to put things in simplified and proper form. So let's start with proper form. Proper form means we don't leave a final answer with the square root on the denominator. So I'm going to multiply the top and bottom, so I get 4 square roots of 91 over 91. Now when I look at this formation right now, I'm going to come back to, does it need a positive or negative at the very end? When I look at this, I have to make sure it's simplified. See how there's 3 different terms here? These 2 are like terms. They don't have a square root. Please grab your calculator so you can learn how to use this correctly as a tool. And we're going to take 4 and divide it by 91. On the left-hand side, you're going to see the button that says Math. When you hit Math, we can see that fraction is highlighted. Press Enter twice, and we can see that 4 over 91 does not simplify. I'm feeling really good about this. I'm going to circle it, and I'll come back to it later to decide does it need a positive or negative. This is already in proper form. I'll come back to it later to decide does it need a positive or negative. Okay, a little tricky here with cosine, but we can't have a square root in the denominator. Okay, so on the bottom, I know I end up with 91 because the square root of 91 times the square root of 91, we've already gone over that, is simply 91. On top, you're like, there's 3 different terms. There's 5, square root of 3, and square root of 91. How do I know which ones go together? The ones that go together are like the like terms. So I'm going to grab my calculator, and I'm going to take 3 times 91, and I get 273. 5 times the square root of 273. Now, I got to figure out, does 273 reduce? So you can work with me with this. All right, you ready? Good morning. Let's just start with some larger numbers. Let's start with like 15 squared. So let's start with 15 squared. And let's just check here. And I'm going to go all the way down. You ready? I want you to do the same, and I want you to beat me. You're much quicker with this than I am. So take 273 on your calculator and start buzzing all the way down to 2 squared. You're going to stop as soon as you find a value that produces a whole number when you divide. Grab a calculator, please. Bless you. And we can see here that none of these actually are able to break it down. I cannot break it down using those perfect squares. All right, what does this tell me? Well, I need to make sure 5 and 91 don't simplify. Okay, they're like terms. So 5 divided by 91, I hit Math, Fraction, Enter, Enter. And if it's simplified, it would show me off to the right. It doesn't, so I'm feeling good about this answer. Now, over here, we're going to do the same thing. But the nice thing about this is if you can really lock in right now, we know there's already a relationship here. So watch, when I multiply by the square root of 3, let's talk about this. What is, and please shout it out, what is the square root of 3 times the square root of 3? Tell me. 3. Okay, so this produces 3. And you're like, I have no idea how she got that. Well, 3 times 3 is 9, and I know the square root of 9 is 3. That's how we get it. So on the bottom, 5 times 3 is 15. So I have 15 on the bottom. And I've already done the work over here. I know 3 times 91 is 273. And I already know 273 does not break down. I'll come back later to the 4 that I've produced right now for answers and determine whether they have positives or negatives. Okay, are you ready? Within your groups right now, I'm going to press pause. I want you to do tangent and cotangent, and everybody must be working in front of me at this time, and I'm going to keep moving forward. So I'm taking times the square root of 3 times the square root of 3. Again, I know this produces the square root of 9, which is 3. 5 times 9 is 15. And I have 4 square root of 3. So I need to make sure that 4 and 15 do not reduce. And if you're not able to do that mental math, we can come up here and we can see 4 over 15 does not reduce. Okay, I'm going to come back to this part. Oh, this is already in perfect form. So this is where a lot of students stop. Please do not say the answer out loud. Just raise your hand. What have I forgotten to do? Chris, do you remember? What do you do? Negatives and positive. All star trig class. This lands in quadrant 3. Only cosine and its reciprocal are positive. So throw a positive with cosine, its reciprocal. Everything else gets 1 negative. A question I often get asked is like, where do I put the negative? Does it go like up top, on the bottom, or in the middle? As long as you put 1 negative sign, whether it's top, bottom, or middle, it will be the correct answer. Let's take a look at this difficult problem. So how do I find this? This just tells me I'm going to go to the left, and this tells me I'm going to drop down. So I'm going to go to the left because it's negative, and then I'm going to drop down because it's negative. So just go left and drop down. Don't worry so much about the exact location. Always go back to the origin and then straight back up. The angle that is closest to the origin, that is the angle of the triangle that we are going to evaluate for the 6 trig functions. Now I went to the left a distance of 7, the square root of 2. Don't put a negative sign there. Again, this is a distance. This just tells me which direction to move, left or right. I'm dropping down 3. Don't put a negative sign. This just tells me drop down instead of going up. Now, how do I figure out the hypotenuse, or the longest side? I'm going to come up here and I'm going to say, and it doesn't matter which one is A and which one is B. So A squared plus B squared equals C squared. And as I shared with you in the last problem, I suggest anytime you have a square root inside that you're going to write it twice. I know 3 squared is 9. I'm going to write this down twice. And I'm going to explain this as though I have students in class that are feeling confused. How do I multiply? I'm going to take those like terms. 7 times 7 is 49. Now 2 times 2 is 4, and the square root of 4 is 2. 2 times 2 times 49 is 98. So I have 98 plus 9. Well, 98 plus 10 is 108. Subtract 1 is 107. Who ended up with the square root? Now, I haven't tried to reduce it, but who ended up with the square root of 107? Hands up high so I can see. All right, now I'm going to grab this calculator. And again, hopefully you've learned after 9 months with me. If there's an easier way to do things, I'm always looking for that, as long as you understand the mathematical reasoning behind it. So I'm taking 107 and I'm dividing it by 10 squared. That doesn't work. Divided by 9 squared. Who already went, oops, sorry. Divided by 9 squared. Who already went through here and they can see that it never breaks down? Hands up high. Does it ever break down? Nope. So we're going to save ourselves time. This is the square root of 107. Okay, it's time. Here we go. Now, some students, I'm going to tell you, like to do the all-star trig class right away. Whether you do it right away or at the very end, it's up to you. Just make sure your final answer is that circled also has a sign with it. Let's get started. Sine is a ratio of opposite over hypotenuse. So 3 over the square root of 107, and here's the reciprocal, 107 over 3. Cosine is going to be adjacent over the hypotenuse, and then hypotenuse over adjacent, or the reciprocal. Tangent is opposite over adjacent, and then over here as well. Okay, 2 things we're going to work on before we finish this problem. First thing is we're going to make sure that it's in the correct form, which means no radicals in the bottom. And then second, we're going to make sure everything's reduced. So I'm going to throw a 107 up top and write a 107 on the bottom. Now, remember, these 2 like terms have to be fully reduced. So you can use your calculator to try. And we can see they don't reduce. I'm feeling good about this answer. I'm going to come back to positives or negatives later on. This is in correct form. It can't be reduced. Feeling good. Okay, here I'm going to take it times the square root of 107 times the square root of 107. On the bottom, I end up with 107. Now on top, 107 times 2. Well, if I take 107 times 2, I get 214. Let's just make sure that's right. I get 214. Now I need to check, can I reduce 214? Has anybody checked that? Hands up high if you've checked it. Okay, let's do it together right now. I believe 214 may be reducing. Okay, let's try. So a lot of times students are like, well, where do I start with this? So let's try 12 squared. Let's try something that's less than, or 13 squared. And I'm just going to start breaking it down here. 214 divided by 12 squared. I'm going to keep going until I get all the way down to 2. And every time I'm looking to see, am I able to produce a whole number when I divide? For those that are in front of me, can you raise your hand if I'm going at too fast of a pace? Okay? You'll fall asleep on me. Getting close here. Getting close. This is where I believe it may work. Oh, does not work. We're good. Okay, does not work. 7 and 107, we need to show that 7 divided by 107 does not reduce, and we can see it does not. Okay, so I'm feeling good about this. Now over here, as I shared with you in the previous problem, this will be a little bit easier than cosine because I already know 107 times 2 is going to be 214, and I know it doesn't break down. Square root of 2 times the square root of 2 is just 2, and 2 times 7 is 14. Students have asked me in the past, can I reduce these two? They're not like terms. One is a square root, one does not have a square root, cannot be reduced. Over here, we're going to take times the square root of 2, the square root of 2, so I get 3 square roots of 2. On the bottom, 2 times square root of 2 times square root of 2 is 2. 2 times 7 is 14. 3 and 14 cannot be reduced. This is in proper form. Okay, let's go. In this quadrant, Mario, please tell me, all-star trig class, what's the only thing that's positive? Tan. So tangent and its reciprocal are positive. Everything else gets one negative. Whether that negative's up top, down below, or in the middle, it does not matter. So how do we do this third and final problem? So again, you're not going to stress out about where exactly it is. You just need to know which quadrant is it in. So when I'm looking here, I'm going to go in the direction of left and then up. So left and up, I make a dot. I always go back to the origin, and then the key is not to the y-axis, straight down to the x-axis. That angle closest to the origin is what I'm going to evaluate. This is a distance of 4 square roots of 2. Turn to your partner, you have 5 seconds to earn that 8-minute quiz. Why do I not put a negative there? Go. Tell your partner. Distance is always what? Positive. The negative just told me which direction to go. And I'm going to go up 5. Now I'm going to go through this a little bit quicker. So I'm going to take 4 square roots of 2. I'm going to square it, which means I'm going to take it times itself twice. And then I'm going to take 5 squared and set it equal to c squared. This gives me 4 times 4 is 16. The square root of 2 times the square root of 2 is 4. Well, I know the square root of 4 is 2. So I have 32 on this part. And over here of 25. What is 25 plus 32? 57, is that correct? So 57. All right, now I'm going to grab my calculator very quickly and see if I can reduce that. So I'm putting in just 57, and I'm going to take it and I'm going to divide it by 7 squared, and then I'm going to divide it by 6 squared, which whether you write it in 36 or 6 squared. And I'm going to go all the way down here as quick as possible, and I notice that nothing is breaking it down, which means it cannot be broken down any further. This is going to be the square root of 57. I'm going to grab a different marker or different writing utensil. So sine is opposite over hypotenuse. So 5 over the square root of 57, and then I'm going to flip it. Square root of 57 over 5. Cosine is going to be adjacent. 4 squared to 2 over the square root of 57, and then I'm going to flip it. Tangent is going to be opposite over adjacent, and then I'm going to flip it. All right, let's go back up to the first one. All of it correct mathematically except for positives and negatives, but it's not in proper form. So I'm going to multiply both the top and the bottom by the square root of 57. I end up with 5 times the square root of 57 over 57. I know that 5 and 57 do not reduce. I'm going to circle. I'll come back later to positives and negatives. This is in proper form. Here I'm going to multiply the top and bottom times the square root of 57. I think that's going to be 114, but let's just check. I get 114, and then I tried to break 114 down. So I'm dividing by 10 squared. I'm dividing by 9 squared. I'm dividing by 8 squared. And I go all the way down here, 6 squared. There's 7 squared. I forgot about 7 squared. And don't fall asleep on me. There's 7 squared. Here is 6 squared. Oh, is there a chance here? Here's 5 squared. Here's 4 squared. 3 squared. And lastly, nothing breaks down. Okay, so what does that tell me? That tells me that this is going to be 4 times the square root of 114 over 57. I know 4 and 57 do not reduce. Over here, the same thing. I'm going to multiply by the square root of 2. I get the square root of 114 on top. On the bottom, the square root of 2 times the square root of 2 is simply 2. And 2 times 4 is 8. Doesn't reduce. I'm going to multiply top and bottom by the square root of 2. I get 5 square root of 2. Square root of 2 times the square root of 2 is 2. 2 times 4 is 8. These do not reduce. Over here, we're good. Now, are you ready? I'm going to call on somebody. Let's go right here. Jimena, what do you know about the points that are in quadrant 2? Sine is positive, and it's reciprocal. Everything else has one negative inside. Please look up here. Here are the mistakes I've seen students make. They're like throwing a negative over here or throwing a negative here. I want it inside the box so I can clearly see it. Or inside the circle, please.